Okay, now we're moving on to 7b, part 2. Now it's another substitution question. So the question asks us, use the substitution z equals x minus 1/2 to find our same integral in part I, dx over the square root of x outside of 1 minus x. Okay, so we're going to essentially find two ways of expressing this integral, and then the third part is going to show us how we can prove an identity. Okay, so straight away what we do is we write our substitution out, z equals 1 minus x, 1/2, and then we're going to differentiate both sides with respect to x, so dz over dx is equal to 1. So simply dz is equivalent to dx. Alright, and also we're going to make x the subject here, so it's pretty simple. All you have to do is add 1/2 to both sides, so we've got z plus 1/2 is in fact equal to x itself. Okay, so now that we've found those two values, we can now simply substitute these into our integrand. So dx over square root of x outside of 1 minus x is equivalent to the integral of dz, because dx and dz are equivalent, and that's over the square root of, now our x was z plus 1/2, and outside of 1 minus, and now our x again was z plus 1/2. Okay, so that bit's done, so now we're going to be working down the page from now, so that's equal to dz over the square root of, as we found, z plus 1/2, or as I'm going to write 1/2 plus z, and you'll soon see. So 1 minus 1/2 is again 1/2, and now minus z is minus z. But hey, look, this is 1/2 plus z, and this is 1/2 minus z. This is a, what do they call it, a factorization of the perfect squares, difference of two perfect squares. So what we found is that that now is equal to dz over the square root of, now 1/2 squared is 1/4, and z squared is simply z squared. Okay, so now what I'm going to be doing is I'm going to erase this first half, and I continue working this out up top here. So if you need to refer to anything, remember to go back in the video. So now, as we found, dz over the 1/2 minus z squared. So what I'm going to do now in the denominator is I'm going to factor out 1/4. So what does that mean? It means this. So I take the 1/4 out, and as we know, to make 1/4 for 1/4, we times it by 1, so 1. And then what am I going to do? If there's a coefficient of 1 outside of z squared, and I took out 1/4, I have to have 4 out the front here, because 1/4 times 4 is simply 1. So that's how you factor out 1/4 from the denominator. So now we know that 1/4 with the square root sign, as we just did, was in fact 1/2. So I'm going to take the 1/4 out of the square root sign, and that changes to 1/2. Now we've got 5. So now we know that 1 divided by 1/2 is equal to 2. So we've got 2, oh, sorry, that's not x, that's z. 2 dz over square root of 1 minus 4z squared. Okay. And now, as we know, we can write that now as 2 dz over square root of 1 minus 2z squared. Okay, and you might notice now, because there is a 2z here, to make this a sine inverse integral, you need to have the derivative of what's inside the square bracket on the top. And what do you know? We already do. We've got 2 here, and if you differentiate 2z with respect to z, you get 2. So we've actually completed this standard integral. So now that's going to be equal to sine inverse without z over 2. And that is plus c. And sorry, not z over 2. It's 2z. My apologies. Because there is no, it's only 1 for that 1 minus thing. If it was, say, 4 minus 2z squared, then that would be 2z over 2, because 4 squared is 2. So anyways, regarding this, we haven't done it again because we need to leave it in terms of x. So again, we learned that z is equal to x minus 1/2. So sine inverse is now equal to 2, now outside of x minus 1/2 plus c. And as we know, when we expand this, we'll be getting 2x minus 1 plus c. So that's another way of expressing this integrand for part 2. So there you go. So now we'll be moving on to part 3 in the next video.